Thank you. One of the things associated with climate change is heat waves. And in recent years, we have some heat during summer months, quite much. So what I'm going to do is I'm going to investigate into the resilience against the heat waves in Vilnius city. So what is this resilience? It's a more complex phenomena than just heat or temperature. There is a huge difference between a heat wave in a desert and a heat wave in Vilnius city. And the difference is not temperature, it's the population. So the more population we have, the more impact we have from the same degree in the heat. So I will start with the initial data, which is I got it from the Living Atlas. And here we have surface temperatures in Vilnius city for summer months. We have the lack of tree canopy in the city, as the trees are actually providing the shadows, which help to reduce the temperature. And we also have demographics from the official census data. Now, I'm going to combine this into one single number for each block in the city. So to do that, I can aggregate the data by the city blocks and get three different numbers: surface temperature, lack of tree canopies, and also population density. Now, all these three phenomena are both different, have different dimensions, and also some of them are physical and one is demographical. So how could I combine them into one single number? To do that, I have one tool which will do all the required steps: pre-processing, combining, and post-processing to get an index value. So how an index value would look like. Here I have it, the results. By the way, I can run the same tool multiple times and use different input parameters, maybe combine them differently. For example, if I have two results, I may even compare them by using our usual swipe, as you can see here. And if I choose one of these results, I may use identification to get the pop-up and compare how a specific block looks like when compared with others. When making a decision based on this result, I may simply look for the worst situations in the city. So if I use a range here, I may find the worst locations where you have people living in huge residential buildings. And okay, I need to. People living in huge residential buildings in locations where there are almost no tree canopies. And during summer months, these people are actually suffering a lot. So how it could be interpreted with result? Simply planting a single tree would make the highest impact in that location. Thank you. Now I am going to another situation. So another phenomena related to climate change is also very heavy rains. So now in ArcGIS Pro we have a simulation which allows us to simulate water falling from above during a very heavy rain. What I can do is I can distribute a certain amount of water in time, in some time spans. And in this case, I am pouring 50 millimeters of water in one single hour. And usually in such an event, most of the water falls during the initial phase of the rain. And you can see graphically that I can see water accumulating on the surface. I can model very different additional parameters, like, for example, infiltration, how this water is going into the surface. And I can use this also not with only with orthophoto imagery, but also with surface areas, surface cover areas, and also I would be able to see how they impact the existing infrastructure. So thank you.